Hey everyone, welcome back to Robo Request. You ask, we build. Now we bring your creative ideas to life with another exciting Arduino project. And this time we are building something educational, interactive and super fun. This is a digital magnet detector using a Hall effect sensor. Now this project was inspired by a real curiosity about magnetism and how sensor can detect it accurately. Now thanks to Atula Kushinge 1957. Keep your ideas coming, your project could be the next, let's dive into it. Here's what we'll need for this project. One Arduino Uno, one analog Hall effect magnetic sensor, one OLED display with I2C, breadboard, jumper wires, a USB cable for uploading the code and of course a magnet to test it. Let's start by setting up the connection. Take the Arduino and the breadboard. First of all, let's power the breadboard. Connect one jumper wire from the 5V pin of the Arduino to the positive rail of the breadboard and another wire from the GND pin to the negative rail of the breadboard. Insert the Hall effect sensor and connect VCC to the positive rail of the breadboard, GND to the negative rail of the breadboard and out pin to A0 which is the analog pin 0. Now insert the OLED display I2C in the breadboard and connect VCC to the positive rail of the breadboard, SDA to A4, SCL to A5 and GND to the negative rail of the breadboard. Now double check your connections to avoid errors before uploading the code. Now download the code and library files given in the description below. Open the code file in the Arduino IDE. We start by including 3 important libraries. Now what.h first helps in I2C communication. Adafruit_gfx.h handles the graphics part of the display. Adafruit SSD1306.h used to control the OLED screen. Here we define the screen width and height. Most common OLED displays are 128 by 64 pixels. We pass these parameters while creating the display object. The OLED_reset is set to -1 as it's not used. We're using an analog Hall effect sensor connected to analog pin A0 of the Arduino. Now this is the center or idle value from the sensor when no magnet is nearby. Now you may need to calibrate this depending on your specific sensor. We start serial communication to monitor data in the serial monitor. This initializes the OLED. The address 0x3C is the default for most I2C OLED. If the display does not initialize, it prints an error and stops the program. Finally, we clear the screen before starting. We read the analog values from the Hall sensor, then subtract the center value to get how much the magnetic field has changed. This prints both the raw and process values to the serial monitor for debugging. We clear the OLED and set the text color to white. This displays a little and draws a line below it for a neat look. Here we show the value of the magnetic field on the screen in the larger text. Set smaller text and position for the polarity status. Now if the value is positive and large, a north pole is detected. If negative and strong, it's a south pole. If the value is near 0, no magnet is nearby. Finally, we update the OLED to show the new content and add a short delay to make the reading stable. And that's it. Now upload the code to the Arduino. Connect the Arduino Uno to your computer using the USB cable for uploading the code. Select port and board in the same menu and select Arduino Uno. Now click on the upload button. Now once you have uploaded the code to your Arduino Uno, bring a magnet close to the sensor. Watch the OLED show magnetic field strength and polarity in real time. And that's it. Thank you so much for watching. If you found this project interesting and educational, don't forget to like, comment and subscribe to our channel for such awesome builds. This is Robo Request. You ask, we build. See you in the next one.